in this series of videos, I'll be doing this past paper for you guys and hopefully give you some help when you're answering the questions. So I'll be talking through my thinking, and I'll obviously be going into more detail than you need to put in your papers, but hopefully it'll help you to understand how you should answer these questions. So we're going to go through the whole paper. This is from October, November 2020. So last year's exam paper, and it was paper 1 from 3. Okay, so obviously when you read the instructions, remember, obviously importantly, all answers correct to 3 significant figures or 1 decimal place for angles in degrees. Okay, and then obviously we use the gravitational constant, 10 meters per second squared. So very important for when you give your final answers. Okay, let's move straight into the first question. So the first question says we have a particle B of mass 5 kilograms at rest. We have particle A with a mass of 2.5 kilogram. It moves on the table with a speed of 6 meters per second. So they tell us it's a smooth horizontal table, all right? And the moment we read smooth, smooth means no friction, right? Or other words, no resistance to motion. Okay, so there's no loss of energy or anything as the particle moves across the table. Okay, the 2 particles collide and they coalesce. Okay, so we need to remember that the word coalesce means that they are going to become 1 particle, so they're going to join, and we can combine them and consider them as 1 particle. Right, they want us to find the speed of the combined particle after the collision. Okay? So this is a momentum question, and so when we consider momentum and the conservation of momentum, the momentum of the 1 particle with its initial velocity and the momentum of the second object and its velocity, and in this case we're going to have 1 object after the collision, so it must be equal to their combined mass after and some velocity. Okay, so it would help if you're struggling with these questions to draw a diagram. It's not necessary if you can understand the question, but it does help. So we have 2 particles A and B. You can just represent them with 2 round spheres. And let's put some vectors and some directions. So let's consider the direction of motion in that direction. Okay, we have particle A at rest and particle B at rest, right? So it has 0 meters per second velocity. It weighs 5 kilograms. Particle A has a weight of 2.5 meters per second and is moving at a speed of 6 meters per second. Now we want to note the direction that this is traveling in, and we can see from the diagram the only way these 2 objects can collide is if particle A is moving in that direction. Okay, once the 2 particles hit each other, they coalesce, meaning they join, they become 1 particle. Right, we could even call it particle C. Right, there's no obviously loss of mass, and so the mass of particle C will be a combined mass of both objects. Right, now I've incorrectly written this as meters per second. That should be kilograms. So we can visually see now the momentum problem. Okay, so using our equation for conservation of momentum, we can say the momentum of object A, which we will say is the mass is 2.5 kilograms. Okay, now these are velocities, so the direction is important. Right? We've considered the direction of this particle in the direction of motion, so we can consider it as positive, and it's 6 meters per second. Particle B has a mass of 5 kilograms and is moving at 0 meters per second. And because the momentum is conserved, and they coalesce, we can consider their combined weight, so 2.5 plus 5, and it's the velocity that we're interested, the final velocity after collision. So some basic arithmetic here. 2.5 times 6 is 13. 2.5 plus 5 is 7.5. So solving for the velocity, we get 2 meters per second, okay? And obviously, logically, you can work out that this must be obviously going in the same direction as particle A was. Okay, the second part of the question says find the loss of kinetic energy of the system due to the collision. Now again, we need to remember that this was a smooth horizontal table, so there's no friction acting on the object, so therefore there's no loss of energy due to friction. And so energy can only be lost due to the collision, right, in whatever form that energy was. So let's think for ourselves. We want to work out the change in kinetic energy. And they've kind of hinted that it's going to be a loss of kinetic energy. And if we want to consider the change in kinetic energy, that is the final kinetic energy less the initial kinetic energy. So let's think about these two separately, right? Both of them require us to calculate kinetic energy. Kinetic energy is equal to 1/2 mv squared. Right. The final kinetic energy is going to be the mass, and now remember these objects coalesced, so they combined, so their total mass was 7.5 kilograms, and the final velocity at impact was 2 meters per second, and we're going to square that. So there's our final kinetic energy. Now let's consider the initial kinetic energy. If we consider that kinetic energy is energy based on motion, if we look at particle B, it's not moving, and so it's not adding any form of kinetic energy to the system. And so the only object we're interested in, the only object that has any kinetic energy is object A, right? And so we can ignore object B when we're considering the initial kinetic energy because it doesn't have any. So let's go 1/2. The mass of particle A was 2.5 and its initial velocity was 6 meters per second, and we're going to square that. Okay, so we have 7.5 times 4 divided by 2. That's going to give us 45, and we're going to get, what are we going to get here? No, my apologies, we're not going to get 45, we're going to get 15. And we have 36 times 2.5 divided by 2, which is 45. So 15 minus 45 is minus 30. Okay, and this is energy. Energy is measured in joules. Okay, now we were after a negative value because negative energy is an indication of a loss. Okay, not direction. Remember, energy doesn't have direction. It's a scalar quantity. So when we talk about negative energy, we are talking about a loss. And so we can just work, or we can word and say a loss of 30 joules.